Silva has strong belly muscles. He's training a lot every day for belly. 6, 7, 8, 9, and 10. Oh, it's very hot. We are tired.
The antenna I'm going to discuss today is called a Moxon antenna. This antenna was originally designed by Leslie A. Les Moxon, Gulf 6 X-ray, Norway. Mr. Moxon lived in Surrey, England. Mr. Moxon passed away in 2004 at the age of 95. Moxon was well known among the amateur community for his writings on antennas, in particular his 1982 book of high-frequency antennas for all locations. This is a diagram of a 6-meter Moxon that will be the subject of this video. This antenna was designed using the Easi neck antenna design system. Easi neck requires wires to be straight, so where a wire is bent, it must be defined as a separate wire and attached to the original wire. For this reason, the Moxon you see is represented by 6 discrete wires, when in reality it is actually only 2 wires. The driven element in our 6-meter Moxon is 110.7 inches long, and the reflector is 117.5 inches long. Number 20 stranded wire will be used for the elements. The insulation should be left on the wire.
This is the base plate for the Moxon. The dimensions are 10 1/4 inches by 24 inches. And you can see the pattern of holes for the 1/4 inch U-bolts. I'd suggest you want to make the holes, drill the holes with a 5/16 inch drill. That way you'll have some leeway so the U-bolts don't bind on the way in. Now in the center you can see the mass mounting hole, and you want to make that large enough to accommodate the diameter of the mast you're going to use. And you can see the L brackets that I use to fasten the mast to the base plate, and I use a simple radiator hose to make that connection. These are the 4 spreader arms that I will be using to support the elements. Now I'm using telescoping fiberglass tubing here, which is really overkill for this project. The only reason I'm using it is because it's some material that I had left from a previous project. Although I've not used it, I think that 1/2-inch PVC would work just as well for this antenna. 1/2-inch PVC is not very strong, but the spreader arms are not really that long, so I think 1/2-inch PVC will work fine. This is the center of the driven element. The driven element is 110.7 inches long, and of course it's fed in the center. And you can see here how I've made the center insulator. Put a couple strain relief holes and then just threaded the antenna through there to the center conductor, and of course a ground lug for the ground. Now, of course, the Moxon has pigtails for the driven element and the reflector. Now, the pigtail on the driven element is 12.6 inches long. So what I did, you can see here, I just took a staple and crimped the staple 12.6 inches from the end. This is the point at which the driven element is going to attach to the spreader, and then the pigtail will be folded backwards towards the reflector. Now, of course, you need to do the same thing for the reflector, except in the case of the reflector, the pigtail is 16 inches long. So you put your staple at 16 inches in from the end and crimp it down, and that's your connection point for the reflector onto the spreaders. And of course, you do the same thing on the other end. These are the surplus fiberglass masks that I use for my antenna projects. They're very inexpensive. I bought a bag of 12 of them for I think $25 or $30. They're very lightweight and quite strong. I've never used one for permanent antenna installation, but I have no doubt that they would do a really good job. And I've had them up as high as 30 feet with no problems. Now here's a mock-up of the antenna as you would put it together. Of course, the U-bolts aren't there, or the center mast, or the elements, but this will just give you an idea of the physical layout of the spreader arms. One additional thing I'd like to mention: when I put this antenna together and hooked the SWR analyzer to it, I was really surprised at the match. I mean, it was excellent. I just tested 50 to 52 megahertz, and it was anywhere from 1.1 to about 1.7 through the whole 2 megahertz spectrum. And the on-the-air results have been excellent also. And it got me to thinking that I wonder what it would be to nest a 2-meter Moxon inside of this. So I went to Easi and designed a 2-meter Moxon, nested that inside of this antenna, and I found out some very interesting things. First of all, the forward gain on the 2-meter antenna is about 12 dBi. It's less than 2 to 1 across the whole band, and there's there's minimal interaction with the 6-meter antenna. The result being that you can feed both antennas with a single feed line. So what I'm going to do is build a 2-meter Moxon nested inside of here, so that when I put it up, I'll be able to, if I want, work some single sideband or CW, horizontal polarized, on 2 meters. This is what's commonly called a choke balun. To ensure that the Moxon antenna performs as efficiently as possible, we have to insert a choke balun as close to the feed point as possible. A choke balun is basically a 1-to-1 transformer. That means there's no change in impedance from the input to the output side of the choke. Well, now you may ask, if there's no change, then why do we even need a balun? Well, baluns are a fairly complex topic of their own, and the theory and use of baluns is really too broad a topic to be covered in this video. The reason we need a choke balun for the Moxon
and really all other coax-fed antennas, is to stop RF energy from flowing on the outside of the coax. If we don't stop or choke this energy from flowing on the feed line, it's going to do several things, none of which are good. Without the choke balun, the feed line will have a tendency to radiate, which will reduce the efficiency of the antenna. Feed line radiation will distort the radiation pattern and also the front to back ratio of the Moxon. It can also result in RF in your shack. As I said before, you want to put a 1-to-1 choke balun as close to the feed point of the antenna as possible. You can go out and buy commercially made choke balun from a multitude of radio supply stores. They'll be not only too happy to sell you an overpriced, fancy-looking balun in a slick-looking container, or you can do as I do and make your own for next to nothing. Now, the coax choke balun you're looking at is made from about 4 feet of RG58 coax. Now, I suggest you use 6 feet to allow for attaching the connectors. This balun is made by winding 4 turns of RG58 coax on a 4-inch form. I use black electrical tape at strategic places just to help the choke maintain its shape. Now, this particular choke balun will work efficiently from 6 meters through 2 meters. Now we've got all the pieces in place to build a 6-meter Moxon.
There's a picture of the finished product. It's only up about 15 feet. Was working some Aurora today and it was working really well. There you can see the piece of 3/4 inch PVC I've got coming out from the center. That's supporting the coax right into the SO239 in the driven element. There you can see the tails on the director and the reflector. What I've got is some wax string running between the 2 fiberglass poles, and then I've just got the tails tied to the wax string temporarily. There's my special testing platform, which is one of my XYL's failed tomato plant experiences. She was going to grow upside down tomatoes and found that they don't like to grow upside down too well, so she was going to throw that out, and I said, no you don't. That looks like it'll fit my fiberglass mass perfectly. And you know what? It did. They fit on there like a glove.
Hi, this is Don, Kilo 2, Papa Mike Charlie. I'm here tonight to show you probably one of the best made devices that I've seen in a long time. It's a 90-degree right-angle bug built by Tom, Kilo 4, Victor, Ida, Zulu. I'm going to send a little CW with it. You'll see just how smooth this bug is.